Welcome students, welcome back. Today we're going to talk about chapter 14.2, vapor pressure and boiling point. It's not a long presentation. Okay, let's see what we're going to talk about. Evaporation, vapor pressure. Let's think when I have a beaker with 100 milliliters of water. If I leave the water in there for a couple days, what do you think will happen to the volume? Let's think for a couple seconds. And yes, after a couple days, let's say 2 days, the volume will be less than 100 milliliters. So why is that? Water evaporates. So a molecule, they have certain kinetic energy, and we have an average kinetic energy. But some molecules maybe have a little bit more kinetic energy and some less. Let's focus on the molecules that have a little bit more kinetic energy than average. So then they have enough energy to escape the liquid phase, and they can go to vapor. So in water, we know we have London dispersion forces. All molecules have that. Water is a dipole molecule, so we have dipole-dipole interaction, but also water can is forming hydrogen bonds with other water molecules. So there are strong bonds between water molecules. But some molecules have enough energy to escape, and they become a vapor. So how does it work? We see here the picture here. So we have a liquid and some molecule can escape and they're now vapor. And also some molecules will lose kinetic energy and then they condensate. So molecules evaporate, molecules condensate. And at some time we have an equilibrium. It's a dynamic one. Molecules, they escape to vapor and molecules from vapor go back to liquid. So molecules that escape, they create a vapor above my liquid. And we learned it a couple chapters ago. They cause a vapor pressure above my liquid. Now let's come to look about vapor pressure and volume. What do you think will be the relationship between vapor pressure and boiling point? If I have high vapor pressure, does it influence the boiling point? Yes or no? Or other way around, low vapor pressure. How does it influence the boiling point? Let's look at that. So, liquid with a high vapor pressure, so that means they can escape pretty easily from the liquid phase. So if I'm boiling a liquid, my molecules escape as well. So the higher my vapor pressure, lower my boiling point. Or if I have really strong intermolecular forces, like water, it's hard for molecules to escape the liquid phase. That means we have a low vapor pressure. And low vapor pressure, they have then a higher boiling point. So molecules with a high vapor pressure, we call them volatile. So it's easy to escape. One of the final things, let's think about boiling water. I think we talked about it in the beginning of the year. At ground level, so at 1 atmosphere, water, pure water, boils at 100 Celsius. But what about at high altitude? I showed you a similar picture. So when we have a vapor pressure, we have the liquid and the vapor, and that's creating a pressure on my liquid. Somewhere high up in the mountain, we have less atmospheric pressure. So we can say we have less air above this pan, creating a lower atmospheric pressure, pushing down the molecules and vapor pressure less than with a higher vapor pressure. So that means more molecules can escape. Or, in other words, it's easier to boil water at elevation because less atmospheric pressure, we have a higher vapor pressure, easier to boil water. I think this is all what I wanted to tell you about 14.2. What I want you to do, study 14.2. Look at this presentation again. And I have a homework sheet on chapter 14.1c, again, about calculations and energy requirements for phase change. It will be on Schoology. And for Monday, I only want you to read chapter 14.3. That's on Monday, and look at the presentation. And Monday we'll also have our hangout meeting. And on Tuesday, I'm planning to do a tiny quiz, an online quiz on chapter 14, but we're going to mainly focus on chapter 14.1. Okay, that's it for today, guys. Take care, have a good weekend, and see you back next week.